Hello everybody, this is Aaron and I will be discussing redox reactions and how we can identify them using oxidation numbers. A redox reaction is any reaction that involves a simultaneous transfer of electrons between two species. It is composed of two different reactions known as an oxidation and reduction half reactions. Splitting up redox reactions this way allows us to see which species is losing an electron and which is gaining it. It is a transfer of these electrons that allows us to essentially have life. Oxidation of a species can be defined as a loss of electrons. For example, solid sodium is oxidized and produces a sodium ion along with an electron. Oxidation can also be defined as a gain of oxygen or a loss of hydrogen. Reduction of a species can be defined as the gain of electrons. For example, carbon dioxide is being reduced by the addition of two electrons and forming carbon monoxide. Reduction can also be defined as a loss of oxygen or a gain of hydrogen. Oxidation numbers are key to identifying half reactions. A change in oxidation number tells us that it is a redox reaction. For example, let's look at the reaction between carbon and an oxygen molecule. By just looking at the reaction, we cannot tell if there are electrons being transferred. By assigning oxidation numbers, we can see that carbon went from 0 to 4+, and an increase in oxidation number tells us that it is being oxidized, and oxygen went from 0 to -4, and a decrease in oxidation number tells us that it is being reduced. For the sake of time, I will ask that you guys please pause the video and read over the rules for assigning oxidation numbers. Okay, so let's do a practice problem. Example 1. Determine the oxidation numbers of barium peroxide. First thing we do is find the total charge of the compound. No free elements or free ions, so the total charge is 0. Now we want to assign oxidation states. We start with oxygen due to its priority, and according to Rule 6, oxygen in a compound is 2-. But quickly notice that it is a peroxide, in which case its oxidation number is 1-. Since there are 2 molecules of oxygen, its oxidation number is 2-. The sum of oxidation numbers must equal 0, so barium's oxidation number must be 2+. So here's some terminology you guys may encounter. A reducing agent is a reactant that is being oxidized, and an oxidizing agent is a reactant that is being reduced. Consider this reaction of copper metal and aqueous silver. We can see that the copper metal's oxidation number increased, which means it is being oxidized, and therefore the reducing agent. Aqueous silver's oxidation number decreases, telling us that it is being reduced, and therefore the oxidizing agent. Photosynthesis is an example of a redox reaction and is a process where plants take light energy and convert it to chemical energy. It is this chemical energy that allows it to produce oxygen and glucose, which are vital for human life. This reaction occurs in 2 steps. First, light photons from the sun oxidizes oxygen from water to produce oxygen molecules and hydrogen ions. These free hydrogen ions are then used to reduce carbon dioxide, producing glucose. It is from these 2 steps that we have oxygen and carbohydrates. Consider the following unbalanced redox reaction. When attempting to balance the charges, why can't we simply add an electron to the product side?